Imagine gazing into a mirror that doesn't simply reflect your face, but time itself. A mirror so powerful that instead of showing your present, it unveils the infancy of the cosmos. That, in essence, is what the James Webb Space Telescope was designed to be, a time machine of light, reaching back over 13 billion years. Its golden mirrors were built to catch the faintest whispers of creation, to witness the universe when it was still young, fragile, and undefined. Astronomers expected to see simple beginnings, clouds of hydrogen, scattered light, and the earliest sparks of starlight. But what Webb revealed wasn't simplicity. It wasn't a cosmic cradle. It was contradiction, an impossibility written across the fabric of space. For generations, cosmologists built a clear sequence of events. The Big Bang erupted, the universe expanded, the Dark Ages followed, and only slowly did gravity sculpt stars, galaxies, and eventually planets. In this model, complexity was supposed to take billions of years. The deeper you looked, the simpler the universe should appear. Yet when Webb focused on regions of sky once thought to be nearly empty, what appeared broke every expectation. Not faint smudges. Not shapeless fog. But galaxies. Fully formed. Spiraling. Rotating. Alive with stars. And they weren't alone. Image after image, dataset after dataset, revealed entire collections of galaxies too mature for their age. Some displayed elegant spiral arms. Others held bright star clusters. A few even harbored enormous black holes blazing at their cores. These weren't prototypes. They weren't early drafts of creation. They looked like finished works, masterpieces that shouldn't yet exist. It was as though the cosmic clock had been wound forward billions of years too soon. Take one galaxy Webb captured more than 13 billion light-years away. By all prior models, astronomers expected to find only a dim blot of light, perhaps a handful of young stars. Instead, they saw symmetry and structure, arms curling like ribbons, clusters shining like lanterns, and a dense core glowing with intensity. By conventional physics, this was impossible. Galaxies were thought to need billions of years to organize into such patterns. And yet here was a fully thriving one only a few 100 million years after the Big Bang. It's like discovering a skyscraper standing tall in a world where the blueprint for bricks hasn't even been imagined yet. To grasp the scale of this mystery, you have to understand how galaxies are supposed to evolve. In the earliest moments, matter was thin, scattered like mist. Gravity slowly pulled it together into clouds. Those clouds collapsed into the first stars. Only later would those stars merge into the beginnings of galaxies. But Webb's findings suggest the universe didn't crawl toward order. It sprinted. Entire galaxies seemed to leap into existence, skipping steps our models considered unavoidable. And the surprises didn't end there. When Webb spectrometers, instruments that split light into its elemental fingerprints, examined these galaxies, they revealed heavy elements: carbon, oxygen, and iron. These are not the raw gases of a young cosmos. They are the ashes of stars that have lived, died, and exploded in supernovae. This means entire stellar generations had already risen and fallen, not over billions of years, but in an eye blink of cosmic time. Stars had lived fast, died violently, and seeded their galaxies with the chemistry for planets, oceans, and perhaps even the foundations of life itself. The early universe wasn't a silent nursery. It wasn't the calm, gentle dawn that textbooks once described. It was a furnace. A restless forge where space itself boiled with energy. Stars blazed into existence and died in violent collapses. Matter wasn't slowly arranging itself into order, it was burning, collapsing, exploding, and recycling at speeds that shattered everything we thought we knew about creation. And just as scientists were beginning to wrap their minds around this furious beginning, Webb revealed something even more astonishing. At the center of a galaxy, not billions of years into cosmic history, but only a few 100 million years after the Big Bang, it found a monster. A supermassive black hole. Not one the size of a star, but 1 billions of times heavier than our Sun. Even in today's mature universe, black holes of such scale are a puzzle. They're thought to begin small, born from the collapse of massive stars, then grow slowly over billions of years, feeding on gas and dust like cosmic predators. But this giant wasn't a patient feeder. It looked fully grown, standing tall at a time when there should not have been enough material or enough time to build it. It was like finding an ancient oak tree already towering above the landscape in a forest where seeds had only just begun to sprout. Faced with this impossibility, scientists began reaching for explanations that bordered on the radical. Perhaps black holes didn't always start small. Perhaps some were born directly from the fabric of the infant universe, primordial titans forged from ripples in density moments after the Big Bang. Or maybe unseen forces played a role. Could exotic dark matter, invisible, abundant, and poorly understood, have acted as a scaffolding, accelerating growth far beyond what ordinary physics allows? Others pushed even further. What if the rules themselves weren't constant? What if gravity behaved differently in those first moments, tugging harder, pulling faster, reshaping spacetime in ways that only later settled into the familiar laws we know today? These aren't minor adjustments to the cosmic story. They are fundamental rewrites, a new script for reality itself. But the contradictions didn't stop with black holes. The more Webb looked, the stranger the universe appeared. Its instruments began picking up subtle patterns hidden in the distribution of matter, repeating ratios, spiral symmetries, fractal-like geometries. What we once dismissed as random chaos was beginning to look structured, almost coded. As though mathematics itself had been stitched into space-time, leaving fingerprints across the cosmos. And then came a revelation even harder to dismiss. Webb detected faint traces of complex organic molecules floating in what should have been empty voids. These weren't bound to planets or stars. They drifted freely, carbon-rich chains, the precursors to amino acids, the very seeds of biology itself. If confirmed, it would mean that the building blocks of life weren't late arrivals in cosmic history. They weren't rare accidents waiting billions of years for the right conditions. They were there almost from the very beginning. Carried like whispers across billions of years. Waiting for worlds to form beneath them. Life, it seems, might not be an afterthought. It might be a feature built into the universe itself. And then Webb captured perhaps the most haunting image of all. 6 galaxies, arranged like petals around a central mass, rotating in near-perfect synchronization. A formation so unlikely, so impossibly symmetrical, that astronomers nicknamed it the cosmic flower. The odds of such a structure forming by random chance are microscopic. Some argued it was a trick of perspective, gravitational lensing bending distant light. Others suggested sheer coincidence. But for a small, unsettled few, the symmetry seemed too deliberate. Too intentional. Not just matter arranged by chance, but a pattern placed, perhaps waiting for a watcher like us to finally see it. And lurking beneath all of this was a darker, more unsettling question. Does observation itself play a role in what we see? In the strange world of quantum physics, the act of measurement can change outcomes. Particles can exist in multiple states until observed, and in observing, we collapse their possibilities into one reality. But what if that principle doesn't end at the microscopic scale? What if the universe itself, vast, ancient, immeasurable, responds to being looked at? Some Webb datasets seemed to shift between runs. Patterns realigned. symmetries bent. It was as if reality itself was not fixed, but aware of being gazed upon. And so, a chilling thought emerged. Perhaps Webb has not only shown us the past. Perhaps it has stirred it. Perhaps, in looking back, we awakened something that had been waiting to be seen. Because what Webb has revealed are galaxies too old, black holes too massive, chemistry too advanced, and structures too precise to fit the universe we thought we understood.